Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, I'll go over 2021 AIME 2 number 13. In this problem, it has a really short problem statement. It just says find the least positive integer n for which 2 to the n plus 5 to the n minus n is a multiple of 1000. So, when we see this short of a problem statement, what would we do? 2 to the n plus 5 to the n. Okay, let's tackle the 5 to the n first. So how about let's list out 5 to the n. We start with 5, 25, 125, 625, and then go back to 125, 625. So it alternates between 125 and 625 in a while. So we really don't have to worry about the 5 to the n that much. And now, in order for us to have at least n with a 0, we need it to be divisible by 10. So let's try 2 to the n. We start with 2, 4, 8, 16, 32, 64, 128, 256. Now, if you look at those and look at just the last digit, 2486. So it has a cycle of 4. And if we just have n, 1, 2, 3, 4, 5, 6, that has a cycle of 10. So in order for this 2 to the n and these n, in order for it to repeat, we need a LCM of 4 and 10 or 20. So after we list 20, the unit digit will repeat. Now, if we look at the sum here, 2, 5 minus 1, that's not 10. 4, 25 minus 2, that's not 10. 8, 125 minus 3, that gives us 10. So, okay, this has a probability of actually happening. Now, let's list out more. So, now if we have 512, 1024, but that doesn't really matter. We just care about the last 3 digits. 48, 96, 192, 384, 768, 536, 072, 144, 288, 576. And that is 20. And we can list out the corresponding ones. So let's list it out in a more manageable fashion. So that's 6. Wait, my bad. It is not aligned correctly. That's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 4, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's the first 20. And now if we take a look at it, we just want this and this to have a difference of unit digit of 5. If you look through all of these, you'll find out, okay, only the other possible one is actually 0, 72, and 17. So now we know this n has to be has to be 3 or 17 mod 20. Now let's just list out, how about now we have n equals 23. N equals 23, we can have this 8, and the thousands digit will just be 2 to the 3 times 2 to the 20. So this is 576, this is 8, so we can just multiply these together. Meaning we can just have 576 times 8, or that's 48, that is 56, 6, and then 40, so 4,608. So the last 3 digits is 4608, or the last 3 digits would be 608. And now this for n equals 43, we would just have 576 times 608. And we already know what 576 times 8 is. Now we just have to evaluate this part. And this part, only the units digit times the units digit would matter. Because it would be like 576 times 600. And the only units digit would matter in the last three digits. Meaning, now we could just look at the last three digits and add that 608 up there. So we would have 6 plus 608, so that's 208. And then now we have this 2 plus 608, so 808. And then we now have this 8 times plus 608, or 408. And now we have this 4 plus 408, plus 608, which is just 8. So now, after 5 more loops, it goes back to 8, meaning we have a cycle of 5 over here. We can do the same thing with this 17. So when n is equal to 37, we would have this 576 times 72. We have to hard calculate this. Make sure you get this right. So let me just do that real quick. 14, 15, 1,152. That's 42, 49, 53, 35, 40, 32. So the last three digits would be 472. Now, similarly, we could just do 472. That'll be 4 times 6, which is 4 plus 472, so that's 872. And then we would have this 8, or 8 plus 472, or 272. And then now we would have this 6 times this 2, so 2 times 2 plus 472, so that's 672. And then we would have this 6 times 6, so 6, so we have 72 back. Now, in order to have this, we would now have, okay, this is 608. This minus 23. We know. This hundredths digit, we don't know, because we could have one more loop back. So the hundredths digit we don't know, plus this 125. We want this to be 1,000, basically, or 000 when taking mod 1,000. You see, the last digit does add up. However, we can see that maybe this doesn't add up. This would give us a 5, so this doesn't add up. If we do minus 43 plus 125, that is going to give us a 3. Actually, my bad. This would not give us a 5 because it's minus 2. So this actually would just give us a 1. And then here we would get 8 minus 3 plus 5, so we get 1 like here. And then we would have minus 4 plus 2, so minus 2 plus 1 minus 1. That will give us a 9, so that wouldn't work either. And then 808, it's the same thing. And that would give us 70. This same thing, that will give us a 50, and this 8 is the same thing. And we just do minus 3 plus 125. That would give us 30. So none of these work. Now let's take a look at the bottom cases. So let's move this a little bit so that we have more space to work with. Over here, we would have 472. That is minus 37 plus, this is still 125 because this is odd and it fluctuates between 125 and 625. Now this would give us, this would actually cancel out, so there will be no carries from the units digit, and this would actually give us 9 minus 3, or 6. Minus 57 plus 125, that would give us, this would be minus 5 plus 9. So that's 4. Similarly here, 77 plus 125. This goes up to 0. Minus 97 plus 125. This actually would give us 0, 0. And minus, this is just 17 plus 125. And this would give us actually 80. So this actually works, and we want this to be 0 again, meaning that we need this 6 minus something plus this 1. We want that to give us a 0. And before, actually, everything cancels out, so no carries. So here we just need a 7, meaning that our answer is n equals 797. And that's end of this problem. So this problem, there are fancy ways to do it, but I decided to do this solution because I feel like everyone will be able to understand this types of thinking and this solution, and you'll be better able to apply these concepts. Maybe some of those hard concepts, yes, you can apply this to this problem and solve it really fast, but maybe for another problem it just doesn't work. But these kind of basic ways of solving the problem, you can always use these. And if you do it right, do some like shortcuts along the way, like me just realizing you already did part of the multiplication. So don't do it again, just do some simple addition to avoid those multiplication, and that would make the problem a lot easier for you. That would be my takeaway for 2021 AIME 2 number 13, and I'll catch you in the next episode of Investigation. And farewell for now.